This is video number 3 for sample exam number 2 for Math 107. For this problem, you have a little practice with negative exponents so you don't forget what they mean. Remember that x to the minus 2, for example, is 1 over x squared. Right. If I had 1 over x to the minus 4, I could move that up to the numerator and the exponent would change sign. That's the rule for negative exponents. So when you need to evaluate a number, although you could write it like this in chemistry, that might be perfectly fine. In fact, it's done that way instead of writing all these fractions. But when you go to evaluate, you need the exponents to be positive. So for example, if I had 5 to the minus 2, I have to write this as 1 over 5 squared before I can evaluate what's going to happen to that 5. In that case, it's going to be squared, so I get 1/25. So that's the first thing in this problem that you have to work on. And the second part of this problem is that the scope of an exponent is only the next variable or the next number or whatever is in parentheses. So if I have 4i to the minus 2, the minus 2 itself only pertains to the I. The 4 isn't within the scope of the exponent. On the other hand, if it was like this, then the 4 would be part of the minus 2. You see that difference? That's an important difference. Up at Fairbanks, if anyone's thinking of transferring up there, they have a list of unforgivable errors, and I believe this is one that's on the list of unforgivable errors. A forgivable error is like, that's forgivable. But this is not forgivable. This is just a careless mistake or just thinking about something else or who knows. To make a mistake with these exponents shows a conceptual error, and that's why it's on the list of unforgivable errors up there. So I want you to be real clear on that. Let's try to do this problem now. Okay, so I have 4i to the minus 2. All right. Again, the minus 2 only pertains to the I. Since that's a negative exponent, if I put it in a denominator, it then becomes positive. Now I can evaluate it. I squared is negative 1. So 4 divided by negative 1 is negative 4. And that's the answer you get. In this case, you're going to compute some things about a trajectory of for example, a pop ball rocket. And what we're concerned with here only is the vertical motion, the straight up and down motion. To do both the vertical and the horizontal motion, you need to take trig. For this case, I give you the equation. You just have to know how to use it, and usually it's fairly well explained. Y is the height of the rocket above the ground. Y naught is the launch height. In this case, the person was on top of a 20-foot building, so its launch height is 20, and that's why the 20 goes here. Again, when you have a problem like this, you don't know what to do, even if you know what to do, the first thing to do is just write that formula right like this. Y naught plus the velocity times time minus 16t squared. Okay, there's your formula. Now write it in all its generality. Then on the next line, substitute the numbers that you know. Okay, what do I know here? I know that he shoots off this pop bottle rocket on top of a 20-foot building. I know the launch height is 20, so I can replace the y0 with 20. Okay. It has a velocity of 50 feet per second. That's velocity. So I can put the 50 in here. 50t minus 16t squared. Okay, I got that much done. And now the rest of the question says, how long does it take for the rock to fall back down and hit the person on the top of the head? Well, how high is his head off the ground? He's 4 feet tall. Obviously, after he shot it off, he leaned forward. But okay, he's 4 feet tall, and it's a 20-foot building. All right, 24. There you go. That's how. And now I want to find the time. So here's the equation for the trajectory of the rocket, and you can just put it on like this. Later on, we'll get this part in here, but I wanted you to see that. Again, when you have to do a problem like this, write down the formula. The next line, substitute in. This allows you to go right back and see what you did. 20, why not? Okay, that does make sense. V50, that makes sense. Nothing to change out here. The height of the rocket when it comes down, the one I'm interested in, 24. Okay, here's the solution for the problem we talked about. I'm going to write it over here so you know what I'm talking about. 24, and it's explained in the handwritten, the online written sample exam. So 24 equals 20, remember that was the launch height, plus initial velocity of 50, t minus 16, t squared. There's an equation I want to solve. Obviously, the part I don't know is time. And this is a quadratic function because it's got the t squared. Right. In order to solve a quadratic like this, you need to get it equal to 0, which means you need to subtract the 24 from both sides. And I'll write it in the more standard form. 24 equals, let's put the t squared first, and the 50t goes here, and then and a minus 4, because 20 minus 24 gives me a negative 4. Now it's in the form where I can do several things. Mainly I could factor it, but doesn't factor easily. Or the second thing I can do is use a quadratic formula, but I can only do that when it's in this form. So now, having done that, I can make the identification. A is minus 16, B is 50, and on actual exam the numbers are better than this. C is negative 4, and no calculator, of course, so you've got to work it out. So how do you do this? First thing you do is what I've been trying to instill in you, is to write the formula, the quadratic formula right here. There it is, t equals this. Now put in all your values. Here's the minus 50 because b was 50. 2 times minus 16, or a was minus 16. And go ahead and put in all these. Now do your arithmetic here. Don't do, trying to, occasionally, people write an equal sign here, and let me get rid of that on there so I can show you what not to do. Knowing what not to do is almost as important as knowing what to do. Okay, sometimes people go like this, and then they write an equal sign, and they decide to work out this and go 50 squared, that's 2500 minus, so that'd be 3 negative signs, so it's negative, okay, 256. So then they write this all out here, work this out, and then try to recoup that square root. Only write equal signs between things that are really, truly equal. This is not equal to that, so you shouldn't do this. Okay, and it's also better to line up your work, not to have neat handwriting, because obviously I don't, so I can't require that. But by lining up your work like that, your errors just go way down. Your error rate goes down. So in this case, there was a calculator used here to come up with this leading number, plus or minus, and then working out the rest of the terms here, you find out that t equals 1.56 plus or minus 1.48, and those are your solutions. All right, what does that mean? If I use, I wanted to say something else. Oh, the other thing I want to say is, and you probably know this already, but I'll repeat it here. When you write the quadratic formula, I want you to write the minus b over 2a here, plus and minus sitting by itself, and then the rest of the formula divided by 2a. I do not want you to do this, and I'll tell you why in a minute. I don't want you to write all of this, as some of you may have been taught in a previous class, which was fine for that class, but not here. Over 2a. I don't want you to do that. Why not? Okay, here's the reason. Actually, there's two reasons. First reason is that if you have complex roots, they're going to be in complex conjugate pairs. For example, let's assume time was imaginary. This might be 3 plus, say, I4. The other root is 3 minus I4. Say those are your two solutions for your problem. Okay. In that case, the plus and minus came from here. That meant this was the imaginary part, and this was the real part. So by writing it that way, you have separated your real and imaginary if you happen to have a complex solution. The other reason for writing it like this is that this leading term is the x value of your vertex, minus b over 2a. How easy is that? See, that's good. So you have that isolated out there. That tells you what h is right off the bat. Those are two reasons for doing it. Okay, that's not this case. I just needed some numbers. Here you have your two times, one with a plus sign and one with a minus sign. With the minus sign, it's 0.08, and the other one is 3.04. What does that mean? That's all explain to you the meaning of those 2 times. I'm going to give the height of the rocket as a function of time, right? Actually started at 20 because that was his launch height, and I'm just going to draw a little dotted line over here, and then I want 24 here. Okay, so what happens to this rocket is that it goes up here and then comes back down, and of course we decided it was going to hit the fellow on the head here. Alright, look at this. There's 2 times that it's at this height. One is that T1, which is the 0.08 seconds. Alright, and now, pretty fast rocket, and now right here, 3 seconds later, it comes down. So if he didn't get hit on the way up, and he moved his head forward, he would get hit on the way down, and that's the idea here. No, the idea isn't to hit him on the head with a pop bottle rocket. That's just the idea of the solution. The important points are that is to write the equation, substitute your numbers. If it's quadratic and you want to solve it, you've got to put everything on one side and make it equal to 0. That's why you put the 24 on one side. Then you look back and say, can I factor it? If not, use a quadratic formula. When you go to use a quadratic formula, write it this way, separating these 2 parts out. In this case, it wasn't totally necessary to do it, but I want you to get that habit. Then you work through and find the couple times, and the 2 solutions, and then kind of sketch it and give yourself some idea of what you're doing, because then you have a better understanding of the solution.